This is the 5.1 to 5.2 review. Calculators still are not allowed, and this is number 4. So on this one, we've got 3 different problems, or 3 different variations. 4, 5, and 6 we're actually putting together because they're all the same type of problem. And it's testing whether or not you know your properties of the integrals, whether you know those rules and how integrals behave. So I will probably first create something that is visual for each of these because it's easier for me to think and explain things visually. It says if f and g are continuous and f is always positive and a is less than b, which of the following must be true? So first I'm just going to draw a picture so that I can see what's going on. I've got f is always positive, so it's above the x-axis, and I have an a value that is less than a b value. So this first one says if I accumulate from A to B, then that accumulation has to be positive. Well, I can see right now that I'm above the x-axis, so the accumulation is indeed going to be positive. The next one says that if I accumulate from A to B on f minus g, well, this one isn't so much a picture one as it is a property. Remember that the integrals can be distributed over addition and subtraction. So we know that this would be the same as the integral from a to b of f minus the integral of a to b of g. Now if we look over here, we see the a to b of f, which is good, and then we see a plus a b to an a. So that means I've switched these two limits, and when I switch the limits, I also change the sign. So this is indeed going to be a true statement. The third one, if we look at it, oops, sorry, I'm crooked. The third one, if we look at it, seems to indicate that this power can be pulled out of the integral. And in this case, this is like saying, let me add a bunch of cubes. Remember, we're summing up a bunch of things that are being cubed. Is that the same as adding them first and then cubing them? Well, if you remember your algebra rules, that cannot happen. You can't distribute powers ever over addition and subtraction. So because it doesn't work with normal arithmetic in algebra, it's not going to work when we're summing them up with a new symbol. So 3 is not going to be true. If we look at number 5, it says f is an even polynomial this time, and we want to know which is equal to the accumulation from a to b. So if I have an even function, that means it's symmetric about the x-axis, or the y-axis, excuse me, and I go from a to b, and we look at this accumulation here. Is it going to be the same as the accumulation if I flip the picture horizontally? Well, if I take a function that is even, that means that f of x is the same as f of negative x. So this is indeed exactly the same as that one. So 1 is going to be true. The next one says if I take the absolute value of the function, do I get the same accumulation? Well, let's think graphically about what happens when you take the absolute value of the y coordinates. What that does is it pops up whatever happens to be underneath. So if I accumulate from a to b now, I would accumulate from here all the way to here, and this accumulation will be positive, whereas in the original one it was negative. So no, those are not going to be the same. The third one says if I accumulate from the opposite of b to the opposite of a, am I going to get the same thing? Well, you can see that this is negative on the left, it's also negative on the right, it's positive on the left and positive on the right. So yes, this is going to be the same accumulation. The number associated with this area minus this area, since we're going forward, is going to be the same as this area minus this area. Number 6, same technique, same sort of property test here. It says if the definite integral represents the area between f and the x-axis, which of the following could be true? So I'm going to draw each of these pictures and see if they're true. This one says f is positive and a is less than b. So f is above the x-axis and a is to the left. Is that accumulation the same as the area? Yes, it is, because it's above and we're traveling right. This one says A is greater than B, so A is to the right of B, and F is negative. So if I accumulate from A to B, I'm going backwards on a negative, so I'd have negative delta x's times negative f of x's. That accumulation would be a positive number, and that positive number would be the area, so that works. The third one is I've got A less than B, and f is negative. So in this case, if I accumulate from A to B, I'm going to get a negative number. So the accumulation from A to B on f will actually be the opposite of the area. So this one is not going to be the same as the area.